Hello everyone, my name is Xian. I'm a PhD student of the Dr. Nation at the Hong Kong Polytechnic University. The work title I share today is the Targeted Deeper Brain Stimulation by Non-Invasive Ultrasound. I will start with the background. First, let me show some of the methods that are utilized in the brain stimulation, such as electrical, chemical, thermal, optical, and magnetic. Actually, it is an internal goal to develop a technology to combine the non-invasive, selectivity, temporal resolution, and the spatial resolution advantage to get the very perfect brain stimulation. Today I'm going to introduce our strategy, which is based on ultrasound. Ultrasound is a well-recognized mechanical wave which carries a frequency above the auditory frequency. It can be dynamically forced into the deep brain region non-invasively through the skull, and its waveform can be engineered easily to form different spatial, temporal resolution. So here's our scientific problem here. Whether we could develop the targeted neural excitation strategy using non-invasive ultrasound through the activation of the mutant of the large conductor mechanosensitive ion channel. Here is the result. First, to figure out whether mascot can sense these cells and neurons to ultrasound, we first check the expressed mascot in the two large T cells, and the data shows that the cells expressed mascot have the higher calcium influence compared to the control group when treated with the ultrasound. And also we use the similar method to treat the neurons expressed mascot, and the data also show that the neurons expressed mascot G22S will show the sensitive to the ultrasound stimulation by the check the calcium influence. And then we explore our experiment in vivo to test our system. We sensitize the neurons, the cortical motor cortex with the mascot virus and control virus. Data shows that no different membrane potentials with the control and mascot group, and we enable the neuronal activity by the CFOX staining, and the data show that the region expressed mascot showed higher the CFOX expression compared to the control group. And also, the mascot group showed much higher muscular contraction compared to the control group. And next, we explored the spatial selectivity of our ultrasound stimulation methods. We choose the deeper region with the dorsal, the medium striatum here. And the data also shows that only the mascot expressed areas in the DMS stimulated with the ultrasound, the CFOX expression is higher than the controlled side, and also the cortex above the DMS do not show the CFOX expressed very well. And we also use the fiber photometry to record the calcium activity in the anesthetized mice, and the data shows that low intensity ultrasound stimulation could trigger the neuronal activity in the mice, which is the DMS expressed mascot G22S here, and no valid obedience change in the fluorescence was observed in the control mice under the same stimulation condition. And we also check the mice antibody and the staining the brain slide with IBA1 and Casper3 to figure out the overexpressed mascot did not influence the general health in mice. So let me make a conclusion here. Ultrasound can activate the mascot, and the non-invasive and the selective brain stimulation strategy was developed. And the deeper the region can be selectively activated by ultrasound, the spatial and temporal resolution are achievable. And that's all. Thank you very much for your patience.